Hello students, coming to the third semester portions, we have a quick review on integration. The process of integration is opposite to that of differentiation, and the result of integration is a higher grade function than that of differentiation. Integrals can be defined using the limit of Riemann sums. There are two types of integrals. First is a definite integral and the second one is a indefinite integral. As an example, we can write the integral of sin x as integral from 0 to pi sin x dx, which is called a definite integral. Generally, if we write integral sin x dx, it will be an indefinite integral. Then there are some relationships between integrals and differentials. Integration is a process opposite to that of differentiation. Therefore, integrals are called antiderivatives. There is a logic for saying B is the son of A, and so A is the father of B. The same logic can be applied in case of integrals and differentials. Hence, a formal definition, by depending on the definition of derivatives, can be seen as follows. If we say that differential of capital F of x is small f of x, then the integral of small f of x is capital F of x. Because of this reason, integrals are called antiderivatives. Then we have some familiar examples. You know that the differential of sin x is cos x, and so integral of cos x can be written as sin x. If we differentiate x square divided by 2, note that it is x square divided by 2, then it is 1 by 2 into derivative of x square, 1 by 2 into 2x, 2 cancels and the result is x. And so the integral of x result is x. Starting from the result, we can write the integral. Integral of x is, when we differentiate x square by 2, we get the result of x. Therefore, integral of x is x square divided by 2. Coming to the differential of e raised to x, we know that the same result is obtained. Differential of e raised to x is e raised to x itself, and so integral of e raised to x is e raised to x itself. Then we can compare between differentiation and integration. Integral does not exist at a single point, but differentials are defined at a point. Integrals are defined over closed intervals, but differentials are not defined over intervals or not more than one point. And note that integral from a to a, when the lower limit and upper limit are equal, integral from a to a, any function f of x dx equal to 0. Then we have similar rules for sum, difference and scalar product of functions while calculating differentials and integrals. Differential of u plus v equal to differential of u plus differential of v. Integral of f of x plus g of x equal to integral of f of x plus integral of g of x. And when we replace plus by minus sign, we obtain the difference rule for differentiation and integration in a same manner. Consider a scalar product c into u. U is a function of x, c is a scalar. Then its derivative is defined as c into derivative of u. In a similar manner, when we consider the scalar multiple of f of x, k into f of x, given k into f of x, its integral can be calculated by multiplying integral f of x k times k into integral f of x dx equal to integral k f of x dx. But in case of product, the rules are different. We have a product rule called differential of uv equal to u into derivative of v plus v into derivative of u in case of differentiation. But the rule is not same for integration. That is, while calculating the integral of product of two functions, you know that there is a rule called the integration by parts. First into integral of the second minus integral of derivative of first into integral of second. Or in some cases, given product of functions, if one is a derivative of given two functions, one is a derivative of the other, then we apply chain rule and substitution. That is, there are similarities and differences between the rules in or properties in differentiation and integration. Thank you. We can come to the details in the next classes.